In this lesson of section 7.7 in functions and equations, we will be discussing four terms. The first one is called the relation. It is a set of ordered pairs. Remember when we were working on the coordinate plane and you had an x and a y coordinate? Both of those together are called an ordered pair. The second term is domain. It is a set of all the x values. Another way it is described as all the input values. It's the first number in an ordered pair. In this example that we have here, we have example of ordered pairs as a set of 1 and 0, negative 1, 1, 2 and 3. The set of domain for these ordered pairs would be 1, negative 1, and 2. So if you're asked, what is the domain of this set? It would be 1, comma, negative 1, and 2. Our third term is range. It is a set of all the y values, or all the output values. It's the second number. So in this same example, the range would be 0, 1, and 3. It is what's known as the y values, or the output values, the second number. And our final term for this section would be function. Function is a relation in which each value of the domain is paired with exactly one value in the range. So let's note in example 1. We have the ordered pairs 1, 0, negative 1, 1, 2, and 3. This is known as a function because each of the domain is paired with exactly one value in the range. In this next example, I'll put example 2 here. We have the ordered pairs 1, 0, 1, 1, 2, and 3. This is not a function. Because this one is paired with 0, but it is also paired with a 1. So this is not considered a function. In our final example, and I'll put the 3 here for example 3, we have the ordered pairs 3, 2, 5, negative 1, and 3 and 0. This is not considered a function either. It is not a function because the 3 is paired with the 2, and yet 3 is also paired again with a 0. So in your exercises, and you'll be having questions asking, is this relation a function or not? You will need to make sure, in order for it to be a function, that the dominion, the first number, the input, is paired with one and only one range. So let's review our terms one more time. We have a relation, which is a set of ordered pairs, x and y. The domain are all the x values. They're considered all the input. It's the first number. Then you have a range, which is all the y values, which is the second number, and a function. And a function is a relation in which each value of the domain is paired with exactly one value in the range. So in your examples, we have example number 5. You can use an input-output table to find the range of a function. So if you'll notice here, in this long rectangular box, is the type of example that the book gives. But what we're going to be making, as far as an input-output table, is a table such as this. A very long T table, if you'd like to say it like that. And we're going to determine what the range is. Remember, the x is the domain, and we are going to input these numbers in this equation to determine what our output would be, what our range would be. So what we will do is we will plug in negative 2 where the x is. So in our first example, we have y is equal to negative 2 times negative 2. Negative 2 times negative 2 is 4, so y will equal 4. So when x is negative 2, y is 4. In our second example, if our input is -1. Y is equal to -2 times -1. Y will be equal to 2. So if our input is -1, our output would be 2. Hopefully the next one you can do in your head. If you have a domain or an input of 0, y is going to equal 0 because -2 times 0 is 0. So our range or our output would be a 0. If, in the next example, if our input was 1, y is equal to -2 times a +1, y is equal to -2. Our output would be a 2. And finally, on our last example, if our input was 2, then y would equal -4. So here is our input-output table. Now, we're also asked to determine what the domain is. It will be the set of -2, -1, 0, 1, and 2. Those are all our domains. Those are what we inputted. And then our range is considered the output, which would be 4, 2, 0. And you know, by looking at this right now, I'm noticing an error because I have 2 positive numbers too. So if my input was a positive 1, my output would be a -2, so I need to put a -2 there. And then -4. So note, our input are the x values. Our output is the y values. You will be asked to make an input-output table, and this is the type of table that you will use. Again, just as we did, we went back and checked our work. Now we have the range is 4, 2, 0, -2, and -4. In number 6, we're going to make an input-output table for the following functions. You're going to use -2, -1, 0, 1, and 2 as the domain. So I'm going to come to my table and write each of these values here. Now, in order to determine what the range is or the output, I'm going to plug in the domain in each one of these. So in our first example, y is equal to 4 times -2 plus 3. All I did was plug in the -2 where the x was. 4 is equal to -8 plus 3. Y is equal to -8 plus 3 is -5. So I'll come over here and put -5 for my range. Next example. 4 times -1 plus 3. Y is equal to -4 plus 3. Y is equal to -1. If 0 is my input, 4 times 0 is 0, plus 3 would be 3. So we could do that one in our head. Possibly the next one, if we plugged in 1 where x was, that would be 4 times 1 is 4. 4 plus 3 is 7. So in this one, 7 would be our output. And finally, on the last, if we plugged in 2 for x, 4 times 2 is 8. 8 plus 3 is 11. So our output would be 11. So in this next example, the set of range would include -5, -1, 3, 7, and 11. Again, all we did was we had an equation. We plugged in our input, our domain numbers, in order to determine what the range would be. Okay, so in B, we have y is equal to 2 5/10 times x. Let's plug in the set that we're going to use for our inputs. And you can use this in your homework too. Now, you are going to plug in wherever there's the x in the equation, you're going to plug in each of the domains in order to determine what your range would be. So you're going to plug input -2 times 2 and 5/10, -1 times 2 and 5/10, and so on. I'm going to pause the video so we can come back and check our answers. Now our output, the range would be -5, 2 and 5/10, 0, 2 and 5/10, and 5. Now, in some examples, you are asked to write a function rule by the input-output table. So a function rule is exactly what we did on the previous page. In these examples, this was our function rule here. And in this example, that was considered our function rule. So now we need to determine what our function rule is here for this table. A simpler way to say, okay, what did you do to x to get y? What did you do to the input numbers to get the output? One easy way to determine what that might be is to, if you have a 0, look at the 0 and see what rule it is. What did you do to 0? What did you do to the x to get 2 and 5/10? Let's see. It looks like we added 2 and 5/10. So could it be x plus 2 and 5/10? Okay, now that works for the 0. Let's see if it works for 1. Okay, 1 plus 2 and 5/10. Yes, that is 3 and 5/10. What if I had 2 plus 2 and 5/10? Yes, that equals 4 and 5/10. So it works for 3 of those. So our function rule for this example would be x plus 2 and 5/10 will equal our y. So the function rule for this example is x plus 2 and 5/10. Again, try to determine a strategy as to what you did to the input to get the output. If your number is increasing, then you could possibly be adding or multiplying. If it's decreasing, you possibly could be dividing or subtracting. So in 8A, B, and C, let's look at each of these tables to determine what the function rule is. Now I'm noticing in A, I'm look at 0. And if my input is 0 and I end up at -3, I'm decreasing. I'm decreasing by 3. So if I took my x and I subtracted 3, I would get -3. That works well here. If I took my x of 3 and subtracted 3, I'd end up with 0. If I took my 5 and subtracted 3, I'd get a 2. So the function rule for this would be x minus 3 is equal to y. Now it's asked, is this a function? Notice I had that out to the side. Is this a function? As you can recall, in the first part of our notes, a function is a relation, and we talked about a relation being a set of ordered pairs, in which each value of the domain is paired with exactly one value of the range. So we can go through and look at all of our domains and see if they repeat. And they do not repeat. So yes, this is a function. Let's look at example B. Again, our input and our output table. We could start with any of the numbers. I'll start with 2. Let's see, what did I do to 2 to get -1? Well, it looks like it decreased. So I'm either going to be subtracting or dividing. So let's see. 2 minus -3 equals, 2 minus 3 would be -1. So let's try that for 4. 4 minus 3 is not -2. So let's look at the whole picture. Let's look at our input table and our output table. It looks like we're dividing by a negative 2. 6 divided by negative 2, is that negative 3? If I had negative 6, if I had 6 and divided it by negative 2, would I get negative 3? Yes, let's try it again. 8 divided by negative 2, would that equal negative 4? Yes, so let's try one more. 10 divided by negative 2, would I have the output of negative 5? Yes, I would. So my function rule for this example would be x divided by negative 2. Again, you're looking at what you did to your domain. What did you do to your input value? Now we're going to determine, is this a function? Let's look to see if all of our domain is paired with exactly one of our range. And yes, they do not repeat, so yes, this is a function. Let's look at the example C. Input and output. Now this looks, I can tell just by looking at this example that the domain repeats. So this is not a function. So we cannot determine what the function rule is. So your answer for an example like this would be not a function. Because since it is not a function, you cannot determine what the rule is. And in our last example on C, let's look at the input and the output table. I'm looking at my inputs and noticing that as I have my input, my output is decreasing. So I can either be subtracting or dividing. If you look at the 0 and the 0, they stay the same. So I'm going to start with my positive numbers. 3 minus 2 is 1. Okay, let's see if 6 minus 2 is 2. No. 3 divided by 3 is 1. 6 divided by 3 is 2. 9 divided by 3 is 9. So the rule is x is divided by 3. Now again, is this a function? Yes, it is, because the domain is paired with exactly one range.